Well, I'm Andrew Whitley. You're at Macby Hill in the Scottish Borders, and we're going to be looking at our 5-acre agroforestry project here, which mixes trees and arable farming in a way that maximizes diversity and, in our case, produces some interesting research results. We keep geese because they're the best way we can devise of using the grass that is part of our arable rotation. Everything you see here that's above ground has been planted by us and has grown in the last 5 years. When we came, it was just a field of grass, and what we're doing is we've planted a series of strips of trees, and we've created these alleyways of grass or vegetables or cereals which we plant in a 6-year rotation. And the idea is to raise the soil temperature and to reduce the effect of the chilling effect of the wind, so that we can grow crops more satisfactorily, get bigger yields, but also to grow the kind of crops that don't naturally do well at 750 feet above sea level in the Scottish Borders. And that includes experimental work into varieties of cereals: wheat, rye, barley, oats, spelt, einkorn, emmer, and so on, which we're researching to, as part of a project to rebuild the nutritional quality and local self-sufficiency of the Scottish bread supply.
And what led you to this? Because when I first met you, you were a baker.
Well, there's your answer. Because a baker uses flour, which is milled from wheat or rye or other things, and a curious baker wants to know where his flour comes from and why it might differ from other kinds of flour and how we might make it more nutritious. And the kind of baker that I became, i.e. a sourdough bread baker, gets very interested in the reasons why people can eat certain types of bread and not others, and why the whole issue of the effect of our diet on our health and well-being has become a matter of public importance in the last 20 or 30 years particularly, and bread has an important role in this. So what I'm interested in is how I can find the best grains to make the best and most nutritious and tastiest bread, from grains that will grow in the climate that we have, with all its vicissitudes and difficulties. Because after all, that's how people fed themselves 200 or 300 years ago, before the system changed and we started importing a lot of wheat and turning our local grains into animal feed, or even worse, car feed, as we are nowadays.
And the farming, and to do this more integrated system.
The short answer is Martin Wolf, an inspiring cereal scientist who has pioneered two things: agroforestry as a productive commercial system, but also population plant breeding, by which I mean taking individual varieties, crossing them with each other in a very complex mixture or population, and then growing the progeny on. So deliberately subverting the dependence of modern plant breeding on single varieties, where certain traits are exemplified by one variety in which each plant in the field is exactly the same as the next one. And saying, actually, the diversity, Martin puts it brilliantly, he says, what we're aiming for is diversity for adversity. And the idea of population breeding is to provide a diversity within a field of wheat or rye or barley or whatever, a diversity which is capable of resisting any challenge that's thrown at it. It's not saying it will be a disaster if I don't get 10 tons a hectare. It's saying I want to get a crop year in, year out, and I want the crop to do some of the work in terms of choosing which is going to grow well this year and which is going to grow next year, in a way which is adapting, which is harnessing the ability of Darwinian evolution, if you like, to provide an adaptability over time, wherein lies resilience, as it's understood in agricultural terms. And of course, the chances are that if we trade a little bit of productivity, because there is no free lunch, we won't get super productivity and all the benefits of diversity, then we might find that those crops will also provide us with a more diverse and hence more nourishing complex of nutrients and energy source and so on that we need to get from our food, our primary foods. So I was inspired by Martin's integration of population breeding and agroforestry, and particularly when he told me with just a hint of a smile, but a very benevolent sort of smile, that whereas he was getting 10 tons a hectare on his experimental oats grown in strips similar to this one here, between willows as it happened, I think, on that occasion, his neighbour, who was cropping the same large field in wheat for the 17th year, was seeing a breakdown in productivity which had taken his yield below 7 tons a hectare. And he was every spadeful of soil in that field was infested by the wheat blossom midge, and he was running out of road in terms of any kind of sensible solution to growing food on that particular field. A definition of short-termism would be hard to find a better one than that. And yet that is the dominant model. That is what kids at agricultural college are taught to do, and what we are invited to buy into if we go and shop at the supermarkets on the basis of low price and convenience without asking other questions about what our food can do for us. Now, in terms of the agroforestry, the specifics of it, Martin answered on that occasion by his yield figures alone. He didn't really need to go on and explain that the occupation of 3 meters of land every 15 meters, which seems to be a massive drain on productivity, actually works the other way, because not only is there a fertility donation, if you like, or contribution from the strips of trees themselves, in this case alder, only 5 years old. You can see it's grown pretty well in 5 years, and that is a nitrogen fixer, so it's providing services through root exudates and leaf fall and that kind of thing, which is going to benefit the grassland or the crops around, but also because the benefit to the microclimate created in these fairly narrow strips is such that you get greater productivity anyway. And the final killer blow, and this is where that little smile curled round Martin's lips, was that his willow crops he was actually selling for more than the value of the oats on the ground next to it, because he was selling it to basket makers. So there's lots of ways of skinning a cat, and the idea that a massive field with great big combines on it is the only way to grow cereals, if you've got any kind of notion of sustainability, is frankly bonkers. Okay, so here you can see the formation of the strips. We've got willow here, hazel there, alder in the third strip, we've got aspen and other varieties further on, each in a double row, which provide a leaf of protection, if you like, against the wind which blows predominantly from the southwest, roaring up the valley and knocking everything down in its path. And so this has just been cut for hay, this strip here, and the next one has been cut as well. It is regrowing, and the geese are folded onto these strips in rotation, a mob grazing system where they cluster and eat all the grass on a small area over a day or two and then are moved on, which is the most effective way of nourishing the geese, but also fertilizing the ground and getting a good regrowth of grass. And then one in every 6 years, one of these strips is a cereal strip, and one in every 6 years it's a vegetable strip. We also have a polytunnel over here and an orchard, a sort of formal orchard, although we are also growing fruit trees which we graft ourselves onto our own rootstocks and that sort of thing. We're growing those in the strips. And as you can see, not everything works. It's very much a work in progress. And in the foreground there's a lot of, there's an example of an unsuccessful choice of species of willow which simply have died, unlike the different varieties further up the strip which are doing very well. And so we kind of learn what is locally adaptable and try and put those lessons into practice and grow more of what likes to be here, until we arrive at a kind of our own version of climax vegetation, if you like, getting a good balance of a lot of different species growing together. And of course these strips of trees provide an enormously varied number of services, if you want to put it that way, to the local ecology. They aren't just a windbreak. They provide, on a rotational basis, they provide coppice wood for cutting or for using as stakes and building materials and so on. They provide corridors of great diversity where insects and small mammals can be completely safe from predators and so on. And so they are then available to provide biological control of various kinds in what is a 100% organic system with no agrochemicals applied or so-called plant protection products used. And the final element, I suppose, of the strips is something a little bit less commercial, and that is the sense of wonder and beauty that you get just seeing trees growing. And the more variety we can create by interspersing specimen trees, as we are gradually doing. There's a walnut over there I can see, and some apple trees in among our hazels. We're gradually trying to create this balance where we get the joy of spring blossom, the lovely foliage of certain species and cultivars, and then some fruit and nuts at the end of it as our reward. And you know, it's just a system which seems to me surprising now that I'm doing it, that we ever abandoned growing trees and agricultural crops together. We can see obviously from a point of view of pure production that you can't get very large machinery on here, but then we don't want large machinery on here because we don't want to compact our soils, and indeed we want to do exactly the opposite. One of the interesting things about the natural fertilization that is provided by the trees, particularly things like alder, which bring up nitrogen, fix nitrogen from the air and bring up minerals from below, is that in a 50-hectare field, albeit surrounded by trees, the trees only drop their leaves on a small number of square meters around the perimeter. But our strips are fairly evenly covered with leaves at the end of the year, and so we get a good spread naturally of this fertility coming up from the strips, which answers the question which everybody raises: how can you afford to waste so much of your productive land on trees? Well, the answer is this is our fertilizer factory as well as our biodiversity store.
And what about the question that I guess also would ask is that, you, as you said, you can't get machinery on here, so does this require a lot more labour? Is it more expensive for you to do?
Yeah, it does. We do have a small amount of machinery, hand-operated machinery, sort of two-wheel tractor with implements, which makes it doable by one person with a few volunteer helpers or part-time help. But, you know, one person's labour is another person's exercise. And I prefer not to spend money on going to the gym to keep myself fit, but to do something productive here. And, you know, I'm beyond pensionable age, and I'm feeling quite good as a result of the occasional stiffness maybe, but I like nothing better than actually being out here doing the work. And, you know, for me that's a benefit, not a chore.
So are you going to take us and show us where these wheat experiments are?
Follow me. This is what's called summer rye, or sometimes called Swidden rye. It's from a Swedish word, svederuk, or something like that, which is a system I think originated in Finland, where people would, way back when, thousands of years ago, would cut down forest, burn it, and in the ashes, therefore rich in potash, they would plant, when it had cooled down of course, they would plant their rye, which was the first cereal used by people in Scandinavia by a long way. And they would do it in the summer, when it's easy to work the ground and it's not too wet and so on. And the rye would come up and it would look like grass, and they would graze that with their animals during the autumn, when the natural grasses were tending to die off in nutritional quality, and this youngish cereal grass, I mean cereals are grasses, would be full of vitality. And so they would graze that, and that grazing action by the animals would encourage each individual cereal plant, rye plant, to produce more tillers. That means more individual stalks coming out of each plant, and each stalk has a head on the top of it, ideally. So you would increase the natural productivity of the grain, and then in the following year, in the spring, you would keep the animals off it, and it would produce a head grain, and you would cut it. Now, I sowed that in August last year, and we grazed it with our geese in the spring, and we had a very poor, in the autumn rather, we had a very poor germination, so it's very thin, and you can see a few weeds in the front of it. But that is rye, which is nearly ready to cut. And what it does for this kind of smallholder farming is to give you a kind of double productivity, in which the integration of the animals into the horticultural, if you like, or the growing cycle, increases the productivity of the cereals, as well as providing food for the animals. So, and of course, fertility is recycled by the geese onto the place where you want it most, because when cereals grow, you want an application of nitrogen, ideally from natural sources, to increase the protein levels of the grains, particularly if they're bread-making grains. So this is a perfect system for people like us here, and you can see why that might, in a sort of integrated, highly diverse smallholder system, might be actually much more productive overall than the most intensive big-scale chemical agriculture, which prides itself on these big yields per hectare, but their yields of only one thing, and they have enormous costs in terms of inputs and the resultant emissions of greenhouse gases in the manufacture of fertilizers and that kind of thing, as well as the energy use that goes into them. This is our experimental cereal plot. It's about 1,000 square meters altogether, and we've got upwards of 70 different varieties of all the main cereals: wheat, rye, barley, oats, and some less common ones like spelt, einkorn and emmer, precursors of modern wheat. What you can see here are naked oats. This is a modern variety, and you can see by the length of the straw it's giving itself away in that respect, because most modern varieties are short-strawed. The reason why short straw is not such a great thing for organic farmers is because we actually need the height of the grain plant to get above the weeds and produce a canopy of leaves which will actually suppress the weeds, because we're not using herbicides to solve that particular problem. And you can see in some of the varieties as we go up the field, you can see the bigger height of the grains is achieving exactly that effect. So we've got a series of individual named varieties. The ones in this plot here are traditional Scottish varieties of oat, now superseded, but maybe with qualities that we want to rediscover and put back into our growing and our diet. And here we have a naked barley. Naked just means that unlike conventional or typical barley, or indeed oats, the grain threshes out freely, so you get a clean grain out of your threshing, rather than a grain covered with a little husk that has to be removed as a separate operation. And this is a modern variety of naked barley which we're growing for our own consumption, really, but also because it may have a role to play in crossing with other barleys to make something which retains the naked habit but boosts the nutritional density of the barley. And particularly we're looking, in the case of barley, at what it offers most of nutritionally, which is something called beta-glucan, which is part of its fibre component, which is very good for heart health. And it's actually available in higher quantities in barley than in oats, which have got quite a good press in the last 20 years for their beta-glucan content. Here we have some unusual samples of rye, and you can see the rye character is naturally to be really tall, and to my mind it's one of the most beautiful plants. When it's swaying in the wind, there's nothing quite like it. Oats come a close second to it, but rye does it for me. And these came all from Russia, from the Vavilov Institute of Plant Husbandry in St. Petersburg. And this particular little row here, which is called Olga 2, is bred by an 85-year-old professor called Kobylyansky, who kindly gave me a little bit of his seed because he has developed a rye which is low in pentasans. Now, pentasans are those things that make rye naturally very sticky. And while this is not a problem for bakers if they use sourdough techniques to overcome the stickiness, it can be a problem when you're feeding rye to animals as an animal feed, chicken feed and so on, because that stickiness is not processed by their gut flora naturally. And that's why he's grown this. But he told me, I went to a conference where he was lecturing, and he told me that this variety made a particularly nice loaf of bread. So I'm, to my knowledge, the only person outside Russia who is growing this stuff, and I'm very interested to see what it's like when I get enough to make some loaves of bread out of it. Right, what we've got growing here are two varieties of grain sourced from the Vavilov Institute, which I mentioned earlier, which is a big gene bank in Russia and has existed since the 1890s. And these varieties were listed in the gene bank as having the name of a Scottish farmer called Patrick Shirreff, spelt differently in the case of the two accessions, but essentially they are the only varieties that I was able to find on international databases of gene banks that had Shirreff's name attached to them. And I managed to get some seed from there. Now, Shirreff was a farmer in East Lothian in the 19th century who was one of the first and best known of the people who selected and also crossbred varieties, trying actually in his case mostly to increase the productivity of wheat, because by that time, even in East Lothian, even in Scotland, the project of growing grain to supply your local mill to make bread with was already being pushed out by imported grain, and so farmers were turning to productivity, to yield above all, so that they could feed those grains to animals and get value and profit and productivity that way, rather than by selling grains for bread. And so the local self-sufficiency of the Scottish economy, just like the English and the British generally, was undermined by this torrent of grain coming in from other countries. And in 1870, when Patrick Shirreff wrote his book on cereals, Russia was still the main source of grain that was coming into Britain to make our bread, rather than the grain that we could perfectly easily grow ourselves in the fields around us. Thereby hangs a long story, but the story that I want to point to in connection with these grains is as follows. These were in the Vavilov Institute, which wasn't called that, in Leningrad, during the 842 days of the siege of Leningrad, the blockade as it's known in Russian. And during that time, the curators, the scientists who were looking after this mass of grains and potatoes and other plants, were forced to make some enormous sacrifices in order to ensure that this seed survived. You can't leave wheat seed in a gene bank forever, because it will cease to be viable. So in rotation, those seeds have to be grown out. And of course potatoes had to be grown out every year, because you can't store them for more than a year. And so these seeds on the trial plots in the Institute in Leningrad, under siege by the Germans, were guarded by the Red Army with guns to stop the starving population of Leningrad coming and digging up the potatoes or cutting the wheat or the rye. And some of the curators, some of the most gifted scientists there, died at their desks of starvation rather than eat the grains that were in their collections. So when I put these seeds in the ground, held them in my hand and put them in the ground, and now looking at these, it reminds me powerfully of the importance of the gift that one generation gives to another through the seeds that it evaluates and stores and preserves. And in the case of those particular scientists who were looking after this, to them perhaps insignificant Scottish grain, that was a sacrifice that cost them their lives. The reason we're growing all these different varieties here and trying to evaluate their properties is because we've come to a pretty pass, really. Everybody in the food system benefits from the growing of grain except the people who eat it. The people who grow it and who trade it and who make it into bread take profit out of it and actually take qualities of value out of it, which means that when it gets to the final consumer as in the form of bread, it is a devalued, denatured and nutritionally impoverished product. So what we're trying to do is to say, hey, we could do this differently. We could actually pay attention to the innate properties of the grains that we grow, what's in them, how much nutrient, how much mineral, the things that we actually get from our bread, or could get from our bread, the iron, the calcium, the B vitamins and so on. But more than that, we could actually take some control over who grows it and why they grow it, because it's a sad fact that in this country of Scotland, which grows nearly 1 million tonnes of wheat, virtually none of that wheat is used to make bread. It's used for all kinds of other purposes, for distilling into alcohol, for animal feed, for starch production, and for bioethanol, for feeding cars, not people. And this is an outrage against self-sufficiency, but it's an outrage also against the sensible, sane use of resources in a resource-constrained world. Why are we growing so much more wheat than we actually need to? 7 times as much wheat as would feed the entire Scottish population is being grown here. The fields across there, that's barley actually mostly, but those are aimed at not feeding people directly. And this is in a world where we are told that we don't have enough food for everybody to eat. The answer is we're growing, in many cases, the wrong grains in the wrong places. And what we're trying to show here is that by harnessing everything from the extraordinary ability of molecular biologists to analyze what's in grain, to the efforts of smallholders and small farmers to grow grain in a way more in harmony with the environment, to get the best out of the soils in which they grow, and to pass those on through bakers who actually care how much they leave in and bring out of the grains that they're working with, then we can actually end up with a healthier, happier population, which is engaged with the whole food system in a way that it currently it's not. And that's the meaning for me of all this seemingly slightly chaotic diversity that you can see here. Is it's about grabbing a little bit of control. We've got vegetables here, we've got trees, we've got grass, we've got a living example of trying to harness the interactions between things growing in a more natural environment than is represented by the prairie-style agribusiness production, which has become the norm now, and which produces the vast majority of our bread grains. And don't for 1 minute think that we can't produce enough in terms of productivity. What we need is a new way of measuring success in our agriculture, and we are working with others on the idea that if we could somehow reward farmers and growers on the basis of the number of people nourished per hectare rather than tons of produce per hectare, then we would be going some way towards improving the situation. Because farmers don't particularly like being on a treadmill of pressing every last grain out of their land in order to live by their profession. They, I think, would instinctively much rather be nourishing people directly, or perhaps a little bit through animals. But this notion that it's only money that is the arbiter of something as important to us, to our health, and to the health of our environment as food, is an offence against humanity, but it's also an offence against rationality, in my view. We are simply doing this in a way which so obviously serves the interests of small numbers of people in a society composed of 7 billion people and rising, who all have an interest in the quality of the food that we produce from our soils, and of course in the long-term endurance of those soils, which the current system is abusing and wasting and using up in the most catastrophic way. If we could realign our research to the real needs of people, rather than the needs of corporations or individual interests, commercial interests, then that would be an enormous injection of energy and expertise into something really important.
Look at it.